Because for some reason or other the program stopped recording. So this is quadrant 4. To get into quadrant 4 is going to be 360 minus 24,83 divided by 2 give you 167,59 167,59 plus k times 180. K is an element of integers. Okay. Who asked this question? Where to go wrong, Michael?
For the replace angle, I forgot that was a minus, so I changed the first one and the second one.
So you didn't pick up the minus, so you treated it as if sign was positive. Just watch out for that. Okay. Let's look at number 10. What's your LCM here? Sin x cos 4x, not so? So it's going to become cos x times cos 4x plus sin x times sin 4x equals 0. Which rule is coming to play here? The cos double angle, not so? So that's going to be cos x plus or minus minus 4x equals 0. This is because negative 3x equals 0. Which quadrant is negative 3x in? Quadrant 4. Is cos positive and negative in quadrant 4? Positive. So it's just cos of 3x. Now if this is 1, 0 or minus 1, I take it to the graph. Okay? So I draw the cos graph. This is normally 360. So this here is cos of x 0. What is this point? Sorry? 90 or 270. So 3x is equal to 90 plus k times 180, or 3x is equal to 270 plus k times 360.
So is it minus 3?
Why minus 6? Should be 360. Now I'm going to explain the 180 afterwards. Why minus 6? Remember here, I consider that to be into the fourth quadrant. Can you see that? So it's in the fourth quadrant. Otherwise, if you don't want to work with that, you can say, how do we get this to be positive? We say then 360 minus 360. And 360 minus 360 is in the fourth quadrant. And cos is positive in the fourth quadrant. Okay. So divide by 3. So x equal to 30 plus k times 120. Or x is equal to 2 divided by 3 is 90 plus k times 120. Where k is an element of integers. That's one way of looking at it. Otherwise, I could have taken it from here and said, okay, take it to the graph, exactly as we had it in. And the question is, there's normally 360 here. As we know, it's 90 and 270. But we know this happens the solution happens every 180 degrees. That solution happens every 180 degrees then. So instead of writing two branches, I could have just have said 3x is equal to 90 plus k times 180. Okay, divide by 3, so x is equal to 30 plus k times 60 degrees, where k is an element of integers. So where did you go wrong?
I didn't know what to do with like I didn't remove the negative 3x.
So you have the same mistake that she's picking up. Or she has indicated. But you understand now? Okay. Anybody else had any other problems with exercise 6? Okay. Very important exercise to understand. Sorry? So leave it. You're still writing. Okay. So now we're looking at solving equations with double angles and more than one ratio. On page 105. Page 105. Example on page 106. Work example 1. The question says determine the general solution of sine 2x plus cos of x is equal to 0. So what are we going to do first here? What do you think we're going to do first? We're going to change sine 2x. And sine 2x can be written as what? 2 sine x cos x plus cos x equals 0. Now what do we do? Cos x has a common factor. Take that out as a common factor. Now what do we do? We can set each factor equal to 0, not so? So cos x equal to 0 or 2 sine x plus 1 is equal to 0, which means to say sine x equal to negative 1. What do I do now? This can be taken to the graph, yes. Normally 360. And that is your general solution that can be applied. Okay? I'm sure you all know how to do general solution now at this point, no? Am I right? This is example 1 on page 106. Okay. So that will be 0 at 90 and at 270. We just did the solution now. So x equal to 90 plus k times 180. Or you could have written it as x equal to 90 plus k times 360, or x is equal to 270 plus k times 360. Okay? On the side here, we work out our reference angle, so reference x. That's also a special angle, so that's going to give you 30 degrees. So what's the question that should come to mind? In which quadrant is sine negative? In which quadrant is sine negative? 3 and 4. How do I get in quadrant 3? I'm going to say x is equal to 180 plus 30 plus k times 360. So x is equal to 210 plus k times 360. Or quadrant 4. How do we get into quadrant 4? X equal to 360 minus 30 plus k times 360. So x is equal to 330 plus k times 360. Where k is an element of? Whenever it's a general solution, please write that down. Okay? Otherwise you will be penalized if you leave that out. You lose 1 mark. Okay? Any confusion? Let's look at work example 2 on page 106. Okay, so the question says solve for x if 3 sine x equals 1 plus cos 2x is and x is greater than or equal to negative 180 but less than and equal to 360 degrees. So what are we going to do here? What should be done first? You change cos 2x. And cos 2x can be written as 1 of 3. Cos 2x can be written as 2 cos squared x minus 1 1 minus 2 sine squared x, and cos squared x minus sine squared x. Which one of the three am I going to use? 1 minus 2 sine squared x. Why? Because we have a sine. So we can leave it to a trinomial. What's up? That will be simply be what? 3 sine x equals 1 plus 1 minus 2 sine squared x. Everything to one side. So it's going to be 2 sine squared x plus 3 sine x. That's going to give you 2 because minus 2 is equal to 0. So what is this to us now? What is that to us? The trinomial. Not so? So if the trinomial had read 2x squared plus 3x minus 2 is equal to 0, then that would have given us a solution of 3 negative 2 a half, or x is equal to 2 and negative 2. But what is x? Sine x, not so? So in other words, sine x is equal to half, or sine of x is equal to negative 2. Now if you're going to work out arc sine of negative 2 or arc sine of 2, that's never going to work. So that one is out. No solution on that. However, sine of x equal to half, we have a reference here. Reference x is equal to, that's again a special angle. So sine of 30 is what? Half. So then x has to be 30 degrees. So, the question that comes to mind is which quadrant is sine? Positive. In which quadrant is sine positive? 1 and 2. How do we get in quadrant 1? X is equal to 30 plus k times 360. Or quadrant 2. How do we get into quadrant 2? Is 180 minus 30, which is 150 plus k times 360, where k is an element of integers. But remember, it's a restricted domain on the sum. So x has to lie between those values. So where do I start? So x is an element of, and I put 0 in here. If I put 0, what do I get? 30. If I put 1 in, of course it's going to be outside. That would have been 390 degrees. Put minus 1 in, I get negative 330. Also not what I'm looking for, not so. Right, let's put 0 in here, what do I get? 150, and that's what I want, not so. Put 1 in for k, so it'll be 180, 150 plus 1 times 360 is 4, is 510, that's way out, no? Put minus 1 in, I get negative 210, which is also outside. So I don't need to write that, and here's my answer to the sum. Okay, do you guys understand? Any confusion there? Any confusion, people? Any questions? No. I see in the textbook they have included negative 330 and negative 210. But that's not in the given interval there. Can you see the given interval here on top? It's not given there. However, here it says for x is greater than or equal to negative 360 but less than or equal to 360. So they have changed it at the bottom, but they haven't changed it on top. Can you see that, people? So we have answered according to what was asked. Okay. Okay, this is example 3 on page 106. Question says determine the general solution of the equation 2 cos x equals sine upper brackets x plus 30. So what can be done here? If the 2 wasn't here, and you had cos of x equals sine of x plus 30, if that was the case, then I would have changed sine to cos of 90 minus x plus 30. Then I would have dropped the causes. Not so? No? But can I do that here? No, there's a 2 infinite. So nope, not a chance. So what's going to happen here? So expand sine, not so? So expand sine, let's see what you get. So you get 2 cos x equals sine x cos 30 plus cos x sine 30. So what do I do now? What can happen now? Sorry? Change cos 30 sine 30. Not so. Cos 30 can be written as what? Root 3 over 2 sine x plus cosine of 30 is half, so it's half cos x. Now what? No, right? They get over. So I'm going to get 2 cos x minus a half cos x equals root 3 over 2 sine x. Which now gives you 3 over 2 cos x root 3 over 2 sine x. Now what? Now what do we do? What is sine over cos? Sine over cos is tan. So that's going to give us tan. I want tan to stand on its own, so I divide both sides by root 3 over 2 as well. Okay, so that would cancel that. Causes cancel, so it's going to be 3 over 2 divided by root 3 over 2. It's going to be 3 over root 3. Or it's going to be, I think it's 3 root 3 over 3, which is root 3. Which is again a special angle. I think it's 30 or 60. Should be one of the two. So arctan arctan over root 3 is going to give you 60. So your reference angle here is going to be 60 degrees. And what's the question that should come to mind? Which coordinate is tan? Positive. Which coordinate is tan positive? 1 and 3. This covers quadrant 1. With quadrant 1, it's just going to be x is equal to 60 plus k times 180, where k is an element of integers. If you're going to represent it in quadrant 3 as well, it's going to be x is equal to 180 plus 60, which is 240, plus k times 180. Now you don't have to write that down because in tan it's a repeated solution. Can you see that, people? Tan is a repeated solution, so that will stay like that. Okay. Well, that is suffice. That's sufficient for full marks. Okay. If you write the branch for the third quadrant, is not going to get you an extra mark. Okay. I'll just think there's something wrong with you. Okay. People, any confusion here? Am I moving too fast? No, too slow. You're sleeping. Not sleeping. Okay. So no problem so far, no? Right, let's do one more. I think there's one more example. Example 4. One of these sums comes in for the general solution section. One of these exercises. General solution is 7 marks in the exam. So please learn this work. Here's the next one. Example 4, page 107. We are told solve 3 sine squared x minus sine 2x minus cos squared x equals 0. For x an element of 0, x is greater than or equal to 0 or less than or equal to 360. Okay, so what can be done here first? change sine 2x. Sine 2x can be written as what? Huh? 2 sine x cos x minus cos squared x equals 0. Now what? What do you see? Sin x is a common factor. No, there is no sin x in the last term. Did you see a trinomial? If this was 3x squared minus 2xy minus y squared equals 0. If you had replaced sine with an x and a cos with a y, you see the trinomial now? Huh? So if you use your quadratic formula, or if you can factorize, so it's 3x, x, y, y. That's going to give you negative 3x plus xy. It will give you negative 2xy. So what is in x's place? Sine. So it's going to be 3 sine x plus cos x into sine x minus cos x equals 0. Okay. So what do I do with that? I said each factor equal to 0. So I got 3 sine x equals negative cos x. So remember, sine over cos is tan. But you got your tan now. So I divide by 3 to get rid of that 3. The causes cancel. So I have tan of x is equal to negative a third. On the other end, we got sine of x minus cos of x equal to 0. So sine of x equal to cos of x. Sine over cos is tan. So we have tan of x is equal to 1. And from here, general solution. Okay? Yes? Sorry? Quadratic formula. If you substitute this into the quadratic formula, x is equal to minus b plus minus the square root of b squared minus 4ac over 2a. So x is equal to, your b value is negative 2, your a value is 3, and your c value is negative 1. Okay? So, 1 over 3. Should have got a negative 1 over 3. Do it again. It's minus b, so it's going to be 2 plus minus. Just check if this is positive here. You got minus. Remember, this is minus from the formula, and that 2 is also minus. You understand? Okay. So what do we tell ourselves now? Ask ourselves in which quadrant is tan negative? In which quadrant is tan negative? 2 and 4. Remember, tan is a repeated solution. Okay? So what do we have now is your reference angle, your reference x is equal to arctan of a third. Arctan of a third is what? Arctan of a third. 18,43. So it's 18.43. So how do we get into quadrant 2? It's going to be 180 minus 18,43 plus k times 180. It's 180 minus 18,43 is 161,57. 161,57 plus k times You could have gone into quadrant 4 as well, which is going to be 360 minus 18,43 plus k times 1. But remember, tan is a repeated solution. So 1 branch is sufficed. Again, we ask ourselves which quadrant is tan positive. It's quadrant 1 and 3. So my reference x here is going to give you an angle of 45 degrees. In quadrant 1, it's going to be x is equal to 45 plus k times 180. If you're going with quadrant 3, it's going to be 180 plus 45, which is 225 plus k times 180. But again, tan, it will be a repeated solution. Okay, remember now we have a restricted domain here from 0 to 360 degrees. 0 to 360 degrees. So we say x is an element of, it's from 0 to 360. Alright. So if I put 0 through here, it's going to give you 161,57. If I put 1 in there, what do I get? So 161,57 plus 1 times 180. Somebody? Sorry? 3? 57. If I'm going to put 2 in there, it's definitely going to be outside. If I'm going to put negative 1 in here, it's going to be negative 18,43, which is outside. Now do the same here for 45. If I put 45 in, 0 in, into k, I'll get 45 degrees. Put 1 in, I'm going to get 225. Put 2 in, it will be outside. Put negative 1 in, it will also be negative 135, which is also outside. Alright, for homework, I would like you guys to do exercise 7 on page 107. Okay. Then we have one more thing to wrap up in terms of your trigonometry, your compound and double angles. People, enjoy the rest of your day. Good afternoon, class.